Hey dear class 9 students, in this video we are going to discuss everything about separation techniques. In our previous video we have discussed all the aspects of the first half of the chapter, isn't it? We understood what do you mean by mixtures, two types of mixtures, solution, colloids and suspensions, and all about the solution, the concentration terms, solubility, saturated and unsaturated solution. All of that is already over, beautifully explained, and the notes was also attached to the video. And from now onwards, every video that you find in Homeschool YouTube channel, notes, beautiful, my own running notes will get attached to the videos, and please do check it out. If you have not watched the previous video, the link is given in the description as well as in the comment section, and also it is displayed in the form of cards. You can check it out. Okay, yes. So now in this video we will discuss everything about the separation techniques. So we all have understood very well that mixtures contain two or more components, isn't it? So, and we have understood that mixtures can be of homogeneous, yes, and they can be of heterogeneous, right? Here I am not explaining what is homogeneous and heterogeneous. All of that is already over in the previous video. So just check the link which is given in the description. Okay, fine. And now if you want to separate one component from other component, say you have a salt solution here. Okay, what do you mean by salt solution here? Salt solution is nothing but salt plus water mixture. So if I want to separate salt from water, or sugar solution, if I want to separate sugar from water, okay, so we need to perform certain chemical process. Okay, they are called as separation techniques. Okay, so if you want to separate one component from another, one or the other suitable separation technique you have to use. And also remember, there is no one single technique for all kinds of mixtures. Okay, so for different kinds of mixtures, different separating techniques are performed. So usually if it is a homogeneous mixture, and I have already told you mixtures can also be divided into three categories based on the size of particles, isn't it? So you have solutions, you have colloids, very important, all of them we will discuss little later, and you also have something called suspension. Okay, so in solution the size of the particles are very small. Solute particles size is very small. So a salt solution, sugar solution, and solutions are homogeneous mixtures. Okay, so here since the size of the particles are very small, one particle can mix with another particle very nicely. Okay, you will have a uniform composition throughout. So solution is an example for homogeneous type. But the colloids and suspension, so in case of colloids, the particle size is not too big, not too less. Okay, whereas in suspensions the particle size is very bigger. Okay, right? And both of them come under heterogeneous type. Okay, colloids are heterogeneous mixtures, suspensions are also heterogeneous mixture. Okay, we will see the examples of colloids and suspensions little later. And here whichever the mixture is homogeneous, especially all kinds of solutions are homogeneous, isn't it? So whichever the mixtures are homogeneous type, such homogeneous mixtures, if you want to separate components from such homogeneous mixture, then we perform a separation techniques like crystallization. Very important. Okay, so crystallization is not performed for colloids or suspension. Crystallization technique is performed if you want to separate components from homogeneous mixture. Okay, you can also perform another technique called distillation. And the third one that is also mentioned in your syllabus, that is chromatography. Okay, so again in chromatography there are so many techniques, but in your syllabus we are going to understand paper chromatography. Okay, so now coming to the heterogeneous mixtures. Which are examples for heterogeneous mixtures? Your colloids can come under that, suspensions can come under that. Okay, so for heterogeneous mixtures, what are the separating techniques that we can perform is differential separation. So what do you mean by differential separation? Okay, so of course you don't find this heading in your textbook, but you have seen the separation through separating funnel. So there is a special instrument called separating funnel, guys. So using that separating funnel, we can separate one component from another component if the mixture is of what type? Heterogeneous type. Okay, then we also have sublimation. Okay, sublimation is another technique, and then we also have coagulation. So usually coagulation is performed on colloids. Okay, and we do have the other technique here, so that is centrifugation, very important. So in the medical laboratories and all, these techniques are used. Okay, so all these techniques we are going to understand one by one, but before that you should know what are the techniques that we use to separate one component from other component from homogeneous mixture, that can be applied for homogeneous mixture: crystallization, distillation and chromatography. And what are the separation techniques that we can use if it is a heterogeneous mixture like colloids and suspensions? If you want to separate components from these guys, then what are the techniques you will identify? What are the techniques you will perform? Differential separation, that is using a special instrument called separating funnel. Sublimation is there, coagulation is there, and centrifugation also is there. Okay, so out of all these methods you should know which one are used for what kind of solution, what kind of mixture. Okay, yes. So now going ahead, we will first discuss crystallization, distillation and chromatography. Okay, so which are used for the separation of homogeneous mixtures. Okay, so look at here. So before we understand crystallization, okay, let us understand what do you mean by crystals. Okay, so crystals are those solids. Okay, all solids are not called as a crystal actually. Okay, say you can't call sulfur powder as a crystal. Okay, but you can call NaCl as crystal. Okay, so you know here all solids are not called as crystals. Okay, so those solids, okay, the solids which have orderly arrangement, orderly, very very important guys, orderly arrangement of atoms, okay, or particles. Here particles can be atoms, molecules, ions or whatever it is. Okay, so in any solid, if you observe a very orderly arrangement of particles, okay, if they are arranged in a particular pattern, okay, so there are so many patterns of arrangement. So if the patterns are very perfect, if the arrangement of particles are very perfect, then such a solid is called as a crystallization. Okay, so usually suppose we have studied a type of a solution called saturated solution. Okay, so everybody tell me what is saturated solution in the comment section. You have studied in the previous video, no? So how do you define a saturated solution? So comment that in the chat section guys. I would love to read each one of your answers. Okay, so what is saturated solution? Very simple. Say a particular solute, okay, gets dissolved to a certain limit, but after a point at a particular temperature it does not dissolve. Okay, so no more a solute gets dissolved at a particular temperature after certain limit. Okay, so that is called as saturated solution, isn't it? Say for example, I have taken 80 ml of water. So I will add 1 spoon of sugar, 2 spoons of sugar, third spoon of sugar. Maybe the 3 spoons can be soluble at room temperature. So usually what is the room temperature? Obviously it is 25 degrees centigrade to 27 degrees centigrade. Say at this point of time my room temperature is 25 degree. So at 25 degree only 3 spoons of sugar can comfortably dissolve in 80 ml of water. But on adding a 4th spoon, so this is a 4th spoon of sugar, if I add, what would happen? That 4th spoon will not dissolve. It might settle somewhere at the bottom of the beaker only. So now this 4th spoon is that excess. We call it as excess. Okay, it will not try to dissolve in a solution because the limit is over. For 80 ml it is only the 3 spoons of sugar getting into water, but 4th spoon, no, it is not getting into the water, it is not getting dissolved. So now this solution is called as saturated solution. Okay, but if you can heat this, say I will increase the temperature from 25 degrees centigrade to 35 degrees centigrade. So I am just increasing 10 degree temperature. Then do you have chance of this 4th spoon of sugar getting into a solution? Yes. Okay, because you have increased the temperature. So when you increase the temperature, maybe that extra 4th spoon also can get into the solution very well. Okay, right? So now this is what the principle that we are using here. Say I heated at 35. So now that 4th spoon, I mean 4 spoons of sugar, okay, so they are there in this 80 ml of water. Okay, now what I will do it, as long as I maintain temperature 35 degree, all the 4 spoons are nicely got mixed up in the water. But now all of a sudden I will cool. Now again I will reduce the temperature from 35 degree to 25 degree centigrade, guys. What would happen? Okay, so now all of a sudden I am reducing the temperature back to 25 degree. What will happen to that 4th spoon of sugar? Will it be there inside the water or it will come out as a solid? It will again convert back to solid. What is your opinion? Yes, that 4th spoon, okay, that extra spoon of sugar which was there in a saturated solution, no, it got dissolved when the temperature was higher, but automatically when the same saturated solution got cooled, that 4th spoon of sugar will reappear in the form of a beautiful crystals, and that process itself is called as crystallization. Okay, so hope you understood. So now just look at this picture, and here is the activity that is there in your own NCERT textbook. That one I have just made it as a picture for you. Okay, look at here. First you have to prepare a saturated solution here. Okay, so I mean maximum amount of here I think they have taken a copper sulfate. So copper sulfate is a blue color crystals, guys. Okay, so they took a copper sulfate crystals and they added to 25 ml of water, and they have also added dilute sulfuric acid here. So what may be the reason for adding dilute sulfuric acid? To avoid further reactions. Okay, right, because it's a copper sulfate, water is there. Okay, say in case to avoid, if it is undergoing any side reactions, we have to avoid that. Here the chemical should not undergo any side reaction. Okay, the dissolved chemical, the dissolved solid must reappear as pure crystals. That is the intention, guys. Okay, so not to undergo any side reactions, we add dilute sulfuric acid, and nicely we are mixing pretty extra amount of copper sulfate into this water, by heating. Okay, after that we are doing some filtration. See, this is called as a funnel. Okay, there is a filter paper, this is a filter paper, and we are just filtering out. If any impurities are there, we are removing. Actually, crystallization is one of the best method to purify, to get a pure solids. Okay, to remove the impurities from the component, a particular component, especially from a solid component. Okay, so we are filtering. Now this is a beaker of copper sulfate. We are allowing it to cool. So when we allow it to cool from a solution, after it got completely cooled, that beautiful crystals of copper sulfate you will see. Okay, so beautiful crystals of copper sulfate would be formed after cooling, guys. Okay, see, if you want, you can just take this one drop. If it is too much of solution, no, it will take lot of time to observe the crystals. Instead of that, just a drop from this beaker, you put it on a slide. Okay, after some time you would see whatever copper sulfate is there in this single drop, no, all of that will get converted into very beautiful blue color crystals. Okay, so where is the crystallization useful? It is useful to remove the impurities. Okay, so now let us understand what is the definition of crystallization that you can write in the exam. Very important, guys. Okay, so formation, simple. What is crystallization? Formation of pure crystals. Pure crystals. Okay, when saturated solution is allowed to cool. Okay, so when do you observe the formation of pure crystals? Usually when saturated solution is allowed. Okay, so is allowed to cool, right? So crystals are appeared, and that process is called crystallization. And how are you getting a crystals here? So what is the principle involved? The principle is very simple, guys. Solutes. Okay, so here which is a solute in the example? Copper sulfate. So solutes gets dissolved, solutes gets solubilized. Okay, gets solubilized differently at different temperature. Yes or no? See, copper sulfate was fully soluble here when you heat at. Okay, so when you heat at maybe at around 50 degrees centigrade or 60 degrees centigrade, copper sulfate, whatever extra amount of copper sulfate you added, everything got solubilized. But the same extra copper sulfate solution, the moment you cooled, the moment you bring down the temperature at 25 degrees centigrade, it is not solubilized. Okay, its solubility decreased. That is why it reappeared as beautiful crystals. Okay, so that is what we mean by solutes get solubilized in a particular solvent at different temperature. Their solubility is different at different temperature. Yeah, this is the simple way of saying. What is the principle? The solubility of a solute is always different at different temperatures. They behave differently at different temperatures. Because they are behaving different at different temperatures, using this technique we could able to create pure crystals. We could able to separate one component from other component from homogeneous mixture. So that is all about crystallization. Hope you understood. If this is crystal clear, type crystal clear in the chat section, guys. So next we will move ahead to distillation. So distillation is another very, very interesting process here. Okay, and it's a very common process. Okay, so first let me write the heading here, distillation. And this distillation is used for the mixture of two liquids. So when two liquids are mixed with each other, and that too those mixtures must be miscible with each other. Okay, miscible with each other. What do you mean by miscible with each other? Nicely gets mixed up with each other. Okay, so for them it's like, you know, nicely combined very well with each other. Okay, so complete uniformity is there. For example, acetone and kerosene, or let me take a simple example, vinegar and water. Okay, right? Or lemon juice is a liquid, isn't it, mixed with water, nicely it gets mixed up, isn't it? So two liquids which can combine so well is called as miscible liquids. So when you have a mixture of two liquids where one liquid is mixing with another liquid very well, now if you want to separate one from other, okay, say I have liquid A mixed with liquid B here. Okay, so this is a liquid A, liquid B, two liquids are there, A, B mixed very well. Now I want to separate A from B. Okay, so that point of time we carry out this process called distillation. Okay, right? So the definition of distillation itself is this. What is the definition of distillation? Okay, it is the separating technique which is used to separate two miscible liquids. Okay, so everybody repeat this definition in the comment section. Technique which is used to separate two miscible liquids. And what is the principle behind this? Okay, what is the principle? What do you mean by principle here? Logic. What way they are getting separated? What is the chemical logic behind this? Okay, that is what we call it as a principle. Right? What is the principle? The principle is two liquids have different boiling points. Two liquids have got different boiling points, isn't it? When you heat, one liquid gets vaporized at one particular boiling point, the other liquid will get vaporized at another boiling point, another temperature. Okay, so that logic, based on that logic, we are separating liquid A from liquid B. Okay, so suppose liquid A has got a boiling point of around 50 degrees centigrade. It means when the temperature reaches as 50 degree, liquid A's vapors will start coming. It will get vaporized, isn't it? And the liquid B, suppose it has got a boiling point of 100 degree. So liquid B to become a vapor, okay, it will take a temperature of 100 degree. Okay, say this boils at 50 degree, the vapors of A comes at 50 degree, the vapors of B comes at 100 degree. That must be the boiling point difference you should have between two liquids in case if you are trying to separate them using this distillation technique. This is actually called as simple distillation. There are so many distillation techniques, fractional distillation, steam distillation, all of that is there, but you will study all of them in the higher classes. So now as far as 9th standard concerned, be aware of everything about the simple distillation technique. Okay, so now liquid A, liquid B, I am trying to heat this. So first whose vapors will come? Obviously the liquid A's. Okay, so liquid A's vapors are coming, okay, because you know the temperature first achieved is 50 degree. After 50 degree only it becomes 60, 70, 80 and then 100. So if you want to see the vapors of B, the temperature must be at 100 degree. This is a thermometer, and if you want me to explain the setup, see this is called as a round bottom flask. In chemistry we call it as a round bottom flask, and this is a Bunsen burner which is giving a flame is coming. So in the round bottom flask we have taken a combination of A and B liquids, and thermometer is here to check the temperature, isn't it? So to have an eye on temperature. So here the liquids are boiling. The moment 50 degree temperature is reached, though your A vapors, the liquid A's vapors will start and they are moving into this condenser. Okay, this instrument is called as condenser. So this condenser is filled with cool water. So this is filled with cold water, right? So when hot vapors are passing through a cold water containing condenser, that vapor will get converted back into liquid. That is the reason we make the hot vapors passed through this condenser. So this is the tube inside the condenser, only vapors will pass, and surrounding this tube, water is filled. Okay, so there is a small tube inside the condenser through which vapors are passing, and surrounding the tube you have a cold water. So immediately the vapors, when they pass through this small tube inside the condenser, the entire environment is cold around, isn't it? So at that cold temperature, the hot vapors are converting back into liquid. Okay, so here on heating, hot vapors are coming. Now in the condenser, the hot vapors are condensed back, they became back into liquid, and now that liquid is collected here with another conical flask. So now whatever liquid is there in this conical flask, that is actually liquid A. Liquid A is here and liquid B is here. Okay, so that is how we can separate liquid A from liquid B. So how are we separating? Why these two guys are getting separated? Because they have a huge boiling point difference. At this boiling point, its vapors, A's vapors will come, we are collecting, we are making it to pass through condenser, so that vapors are becoming liquid back and that liquid is collected. Okay, so hope you understood the process of distillation. Guys, now the next technique is very interesting technique, that is chromatography. Okay, so first understand the meaning of the word chromatography. So chroma means color. Okay, right? So chromatography is the technique which is used to separate colored component. Okay, so what is this? This is a very, very special technique used to separate colors. Okay, say for example, you have a combination of red, blue and black ink, right? So you have the combination of these three inks mixed together, where say it turned out into some other color. Say the combination of red, blue and black can be in which color? If you know, let me know in the comment section. Okay, you'll have a different color. Okay, not exactly black, not exactly brown, it looks like that. So now this is the ink that you have. Somebody gave this ink which is of very, very different color, looks like black, but seems like there are so many different colors in this ink, where you want to know what colors are there, how many colors are there. Okay, then the best technique that you can go for is chromatography. Okay, so you have a mixture of colors, right? You want to know how many different components are there, what colors are there, right? All of that you can identify with the help of this technique. Okay, and here we use a very, very special paper called chromatographic paper. Actually, there are different types of chromatography. So there is something called column chromatography, paper chromatography. Okay, so many different types are there. All of that you will study in the higher classes. In your level, they have introduced something called paper chromatography. Okay, look at here, and this is a very, very, very special paper. Okay, so this is actually called as chromatographic paper, right? Okay, so how they do paper chromatography is very simple. So first they will take a particular paper and they will draw a one line. Okay, so just maybe 1 inch above from the bottom, they will draw a line. and they will mark with one dot actually. Okay, so just at the center of the line they will mark, that is the reference point where they will introduce the sample. Okay, suppose you have a sample, ink sample is there. In this ink sample 2 or 3 colors got mixed up. Okay, so you want to know in this sample how many colors are there and what colors are there. So that I am calling it as a sample. And to introduce a sample, we will mark at the center of the baseline. You know, this line that we are drawing just 2 centimeter above or 3 centimeter above, no, that line is called as baseline. Okay, so at the center of the baseline we introduce a sample. Okay, so here we are introducing a sample. Now this is a sample, just a drop liquid, it is there in a liquid form, that mixture of colors which is there in a liquid form, no, that we have introduced right at the center of the baseline. Now we will dip this paper, look at here, the paper where the sample is put at the center, just 1 or 2 drops of sample if you put at the center, that's enough. Okay, so after you put the sample, the entire paper is dipped in a particular solvent. Solvent every time need not be water. Okay, depending on what kind of sample, different solvents are used. Sometimes acetone is used, sometimes alcohol is used. Okay, maybe in this case here water is used. Okay, so the paper is kept in a water such that the solvent must touch the baseline and the sample. Okay, so the water level should be till the baseline along with the sample. Okay, so now we all know that when a paper is put into a water, water will spread and go along the water, isn't it? So depending on the attraction between paper and water, the water level rises. So what is rising here? The water level. Okay, the water level rises here. Okay, and now depending on how nicely the components have got attraction with water or attraction with paper, they get separated at different levels. Okay, so the component which has got, so the component which has more attraction with paper, okay, the component which has got more attraction with paper, it will not go along with water. As water level rises, the component which has got more attraction with paper will remain at the bottom only. Say the pink color is at the bottom, that means the pink color has got more attraction with paper as compared to the solvent. See here, look at here, the yellow one is there on top. What does that indicate? That yellow color component, that yellow color having chemical is there, no? That must have had more attraction with solvent. It must have had more attraction with water. So as water level rised up, along with the water, that yellow color chemical also rised up and it got separated and it is clearly visible on top. Okay, so different components have got different attraction capacities with water as well as paper. The component which is more attracted to paper will remain at the bottom. The component which is more attracted to water will travel up and it will remain on to the top. Okay, so it is this principle on which the colors are getting separated. So now the sample which was actually looking in black color is not only a black color, it is a combination of yellow, pink, blue, violet and all of that. See here. So using this paper chromatography, you can find out what colors are there, how many colors are there in a particular sample and everything. Okay, and what is the principle here? On what basis the things are getting separated? What basis or what is the principle? It's very simple, guys. What is the logic on which the things are getting separated? Different components, okay, have different attractions attractions with solvent or paper, anything. Okay, so the one which is very the one which has got lot of attraction and affinity with paper, it will remain at the bottom only. The one which is very happy to go with water, it will go with water. As water level rises and it goes up, isn't it, through the paper? Yes, so that's called capillary action. So as water rises up, the color also or the components also goes away with water. Okay, right? So this is all about the paper chromatography. If you have understood, type understood in the comment section. Okay, so that's all, guys. So what we have discussed: crystallization, distillation and paper chromatography. These are the three techniques that you need to study to separate what kind of mixtures? Homogeneous components of homogeneous mixture. So now let us understand the separation techniques of heterogeneous mixtures. Okay, separation techniques of heterogeneous mixture. So the first one we will try to explore is, I think, let me just show, using a separating funnel. Okay, and this method is actually called as differential separation. So the very first method we are discussing is differential separation. The name of this method is called differential separation. Okay, so in this differential separation, we use a special instrument actually. So there is a special instrument here, and this special instrument is called separating funnel. This is called as separating funnel here. Okay, right? So how does this separating funnel looks like? So this is how it looks like. Right, so it will have a stop knob. If you tighten it, the knob gets closed, and if you can make it loose, as you make it loose, the contents in the separating funnel will come down. Okay, and this is a knob on the top. Okay, this is made up of glass, and this simple instrument is called separating funnel. Using this separating funnel, what we can separate is two immiscible liquids. Okay, so what do you mean by immiscible liquids? So this technique is used to separate one component from another in what kind of mixture? In immiscible liquid type. Okay, immiscible means one component is not getting mixed up with another component that will. Okay, for example, combination of water and oil. Okay, so this is a immiscible liquid, combination of water and anything. Okay, right, so they all are immiscible liquids, where one component is not getting mixed up with another, both are getting separated as different layers. Such mixtures are called as immiscible mixtures. So if you want to separate one component from another from those kind of mixtures, this technique is used. Okay, say if you look at this activity that is there in your NCERT. Okay, right, say they have taken what? Water plus oil combination here. So water is here, oil is here, both are there in a different layered format, isn't it? So in the first step, what do? They take the mixture of water and oil and they will fill it in the separating funnel. Say it's a knob, you can remove this and you can pour that mixture, and this is a conical flask, we call this as conical flask, to collect. Okay, so now when you allow it to settle, you will have a oil layer on top, water layer at the bottom, because water is denser, isn't it? So water is denser, it is heavier than oil. Oil is lighter. Oil is lighter, water is denser. So the component which is denser will go bottom and the component that is lighter will stay on the top. Okay, so now as you loosen this knob, you can loosen it. Okay, as you loosen this knob, so all the water content, say the bottom layer, whatever is there, here the bottom layer is water, all that water is falling away. So on a top, what is left out? On a top, what is left out? All the water once it comes down, no? So here only that yellow color layer you will have. So this is a yellow color layer. Okay, right? Like this you can separate one component from another component, right? So that's all about differential separation, guys. Okay, so usually when you want to separate two immiscible liquids, no, this method is highly used. So now coming to the next method. Okay, yes, next method that we are discussing is usually if you want to separate colloids. Okay, so colloids are heterogeneous mixtures. So let's understand what do you mean by colloids here. Okay, so colloids are heterogeneous mixtures, guys. Heterogeneous mixtures, okay, where particles have size of 1 nanometer to 1000 nanometer. Okay, so we all know that when you have a solution, the component which is present in a smaller amount is called solute, the component which is present in a larger amount is called solvent. All of that I told you in the previous class. Now if this solute particles size is fallen under 1 nanometer to 1000 nanometer, okay, then such a solution is called as colloidal solution. Okay, so here what will happen, the solute particles will keep on moving all over the solution, they will not settle, okay, at a place. Okay, so this larger particles whatever are there, no, they will keep on moving all over the solution. Okay, so there is a very special movement with this solute particles called Brownian movement. Okay, so randomly the solute particles will move everywhere throughout the solution. So this is like intermediate between a solution and suspension. Okay, what do you mean by suspension here? The best example for suspension is say sand and water. Sand and water mixture, what you can observe with this is after some time the sand particles will go down and settle, isn't it? But here in the colloidal solution, that settlement of particles you will not have. Though the particles are quite bigger, they won't go at the bottom of the beaker and they settle. Okay, so they keep on moving all over the solution. So the best examples for colloids is the blood is an example, milk is an example, clouds are an example, smoke is an example. Not necessary that liquid should be mixed with liquid. Okay, combination of gases can be an example, smoke can be an example, fog can be an example, cheese, butter, all of them are examples of colloids only. Okay, they can be solids, they can be liquids, and they can be gases also. But if one of the particles size is coming under this range, then it is called as colloid only. Doesn't matter whether it is a gas, solid or liquid. It's a mixture of so many components, but if one of the components size is falling under this range, then it is called as colloid only. Okay, hope you understood the concept, right? If you have understood the concepts of colloids, type colloids in the chat section. Okay, fine. Right, so now if you want to separate components from colloidal separation, okay, colloidal solution. So separating components from colloidal solution, especially from colloids, if you want to remove one of the component, then we use the techniques called centrifugation. and there is another technique called coagulation. So these two are very common techniques which are used if you want to separate the components from colloidal solution. So now let us understand what is this centrifugation. Okay, so if you look at this picture, this machine is there, no? Usually I told you blood is a colloidal solution. Say the medical people will collect your blood for testing different components. Blood has got so many components, no? RBCs are there, WBCs are there, serum, blood serum has got so many components. Okay, so if they want to test one particular component, first they need to separate the solid part from the liquid part. Okay, so the solid part of the blood is blood cells, RBCs, WBCs, platelets, all these are solid part. Okay, liquid part of a blood is a serum. Okay, we call it as that white color, yellow color, clear liquid is there, no? So that's a blood serum. Okay, so now there are certain components dissolved in blood serum, there are certain components present in solid blood cells. Suppose if they are trying to detect a component from blood serum, first what they need to do, they should separate the solid part from liquid part of a blood. Okay, so for that they use the process called centrifugation. So this is a centrifuge machine, okay, where you have the inner portion looks something like this. So these small bottles are there, no, which carries blood. They are actually called as vials. Okay, we call them as vials. So there are vial holders here. See, 1, 2, 3, 4, 5, 6. In this instrument, there are 6 vial holders. So we will fix the vials there and we will close the lid and we will set the speed. RPM means rotations per minute. So it will rotate with very high speed. What is RPM here? RPM is nothing but rotations per minute. Okay, so when you rotate, when it spins, you know what do you mean by spinning, right? So when it spins, a kind of force gets developed called centrifugal force. Okay, so there is a force that gets developed when you rotate these blood samples with very high speed. How much speed? Look at here, 4000 means 4000 rounds per minute. Okay, that much rotations, that much high speed rotations would happen. Okay, so when it is rotating with that much speed, there develops a force called centrifugal force, and this centrifugal force pushes the material which has got more weight, the denser material, pushes to the bottom side, and the lighter material, it will stay on to the top. Okay, right? So because of that high spinning, the solid part of the blood gets separated from the liquid part. Okay, because the force gets developed, it is that force which is separating solid component from the liquid component. Solid component is heavier, so the force will make the solid component to settle at the bottom. The liquid component is lighter, so that liquid component stays on to the top. Okay, so that process itself we are calling it as centrifugation. Okay, that's it. So we are done with the centrifugation. Now we will go for sublimation. Okay, so before we go for sublimation, let us finish coagulation, because centrifugation and coagulation are the two techniques which is widely used if you want to separate components from colloids. Okay, so after centrifugation I am showing you the coagulation. So coagulation means precipitation. Coagulation, another word for coagulation is precipitation. Let me explain this process with an example. Okay, so we have a colloidal solution here. So this is a mud water. Okay, so mud is a colloidal solution here. Mud mixed with water is there, no colloidal solution. See it all over the solution, it is brown. And let me tell you one more point here. When I spoke about colloids, right? Say here you'll have a solute and solvent. Solute particle size is of this range. Actually, in case of colloid, you don't call this solute particle with the name solute. The solute itself can be called with another name called dispersion phase. Okay, the solvent particles can be called with another different name called dispersion medium. Okay, this is very, very important. So in case of solution, the component which is there in a small quantity is called solute. Component which is there in large quantity is called solvent. But in case of colloids, the component which is there in small amount, usually that component is falling under a size range of 1 nanometer to 1000 nanometer. Okay, so that component is called dispersion phase. So I mean dispersion phase particles are there, no, they are having a colloidal range size. So why am I repeating this? This is very important. So the solvent particles are called with the name dispersion medium. Okay, so now after understanding this dispersion phase and dispersion medium, okay, so here the mud is there, no, the mud particles are dispersion phase, the water and all is a dispersion medium here. Okay, so maybe some components of mud again is actual colloidal particles which are falling under a size range of 1 nanometer to 1000 nanometer. Okay, and our intention is to separate the mud from clear water. Okay, so that is what the agenda here. So what I will do here is, look at here, I am adding white color crystals. These are called alum. Okay, so what is an alum? Alum is a white solid. Usually this is used in the purification of water. If you want to purify water, they will add this white powder called alum. What it will do is, it will make dispersion phase particles to combine with each other, okay, to form as a clot. Okay, and once all the dispersion particles come and combine and form as a clot, no, see here, the moment you add alum, what has happened? Dispersion phase, DP means dispersion phase, dispersion phase particles combine to form clots. Okay, so who is making these clots? Alum. Okay, so alum is making all the dispersion phase particles to come closer and they will form as a clot. Okay, so see here, this is one clot, this is one clot, this is one clot, like this clots are formed. Now these clots are very, very heavier, isn't it? So once all of them have come and formed as a clot, that clot itself is too much heavier. So obviously what will happen, all of a sudden all clots will come at the bottom and they will settle. So that is how you are separating the mud from water. So the water which is there here is a clear and pure water. Okay, so this is called coagulation. Okay, so you are separating the components by making clots. Okay, formation of clots in the colloidal solution is called coagulation. So what is the definition you will write here? What is the definition you will write? Okay, let me show it here. Formation of clots, or these clots can also be called as precipitates. Okay, precipitate. Formation of clots from colloids. Using coagulant. So you need someone to make clots, isn't it? So that someone is called with the name coagulant. Okay, so coagulant, right? Coagulate or coagulant or whatever. Okay, so that process is called as coagulation, or it can also be called as precipitation. Okay, so what is the other example? So here alum is a coagulate. Okay, and now coagulation in everyday life. So you know what, the milk, and now milk is also a colloidal solution, guys. The milk protein is there, no? So that is a dispersion phase here, which is having a size range of 1 nanometer to 1000 nanometer. Okay, to the milk, when you add this lemon juice here, this lemon juice is behaving like a coagulate. Okay, right? So the moment you add this lemon juice, the milk protein will form clots, and those clots, you know, you can separate from the watery part of a milk. That is how the paneer is made, isn't it? So this also is an example for coagulation here. Okay, so hope you understood the two methods which are used to separate the components from colloids. One is centrifugation, the other one is coagulation. So now we will see the other method which is common. Okay, say sublimation. Okay, so sublimation is a common method, guys. Suppose you have mixture of two solids. So here this is a mixture of sand and camphor. Okay, so this is a mixture of sand and camphor. Okay, so I want to separate camphor from sand, and camphor has got very important property. Okay, when camphor is heated, okay, so when camphor is heated, what would happen? This solid camphor is usually present in a solid form. This solid camphor directly becomes a vapor, and this process itself is called as a sublimation. So what is the definition of sublimation here? Solid, okay, converting into vapor. Converting to vapor. When does the solid gets converted into vapor? On heating. On heating. Okay, solid converting into vapor on heating is called sublimation. So now I want to separate sand from camphor. So I will heat the mixture I am taking here, and I am heating here. Okay, when I heat, what is happening here? Camphor is slowly getting converted into vapor. So white color vapors have come, and you know, these vapors, when they touch the walls of this funnel, so this is an inverted funnel, and we stop the escape of vapors. That is why we blocked the way with cotton plug. Okay, so that the vapors can condense onto this you know, funnel. Okay, so the moment the vapors, the white vapors touch onto the walls of the funnel, they get cooled and it will get condensed back as solid. So the camphor crystals will get attached and they get adsorbed onto the funnel, guys. So that is how you have separated all the camphor from sand. So all your camphor went and stuck onto the funnel. Okay, when you heated, what happened? The camphor vapors went up and they touched onto the surface of funnel, condensed, and on condensing it has not become liquid, it has become solid only. Vapor, again the moment the vapors touched onto a funnel, the vapor has become solid. So that's how the crystals of camphor will you know, you will observe them stucking onto the funnel itself. Okay, from the funnel you will collect all the camphor back. Okay, your sand is left free from the camphor. So this is how anything which has got a sublimation property can easily be separated using a process called sublimation. Can all the things be separated using sublimation? No. Okay, only the components which have got this sublimation property can only be separated using this technique. You need to understand that. Okay, so that is all about sublimation here. Okay, so hope you understood all the methods. And now what are colloids? I have already told about the colloids. Okay, everything we discussed about dispersion medium, dispersion phase and everything. And look at you know, different examples of colloid, guys. Milk is a colloid, sauces are colloids, ice creams are colloid, fog is a colloid, and all of that. So now let us see what is this Tyndall effect. Okay, so you know what, very interesting phenomena. Suppose you have this colloidal particles suspended all over. What do you mean by particles suspended? Do you know the meanings of particles suspended through the solution? Suspended means Suspended means they are floating all over the solution. Floating all over. Floating all over. They are not settling at one place. They are not staying at one place. So the dispersion phase particles, the DP particles, DP means dispersion phase here, which have got a size range of 1 nanometer to 1000 nanometer. Okay, so these DP particles always they keep on moving all along the solvent, that is dispersion medium. Okay, so they are like super active, super busy all the time. They don't want to take any rest. Okay, so they keep moving all over. That's what we mean by particle suspended. Okay, so now we know the particles are moving everywhere. Suppose when you pass a white light or any kind of light through a colloidal solution. So this is a colloidal solution. Okay, where the dispersion phase particles are moving everywhere. So the moment the light rays are passed, each and every DP particle will spread this light around it. Okay, so every time a light ray is hitting this, the particle is spreading the light ray all around. Okay, so that is what we call scattering of light. Okay, so scattering of light. Every particle will spread the light all around, right? So this phenomenon is called Tyndall effect. So what is the definition you can write for Tyndall effect? Scattering of light. See here it is mentioned, scattering of light by the particles of colloid. Okay, scattering of light by the particles of colloid or suspension. Okay, scattering can also be observed even in the suspension, like chalk plus water. Chalk water is a suspension. Okay, here the particles are much bigger than colloidal particles. Okay, so suspension or colloids, both of them will show Tyndall effect. What is Tyndall effect? Scattering of light by the particles. That's it. Okay, so when the light gets scattered through the solution, when you see from the right angle, say now my eye is right angle to the path of light. Even if your eye is here, it is like right angle to the path of eye, isn't it? So when your eye is right angles and you are sitting in the right angle direction to the path of light, with your eyes you can neatly see the path of light. Okay, so that is what in the cinema hall also, right? So sitting in this position, when you look up, these light rays you can see, because the atmosphere has got smoke particles, dust particles, and these smoke and dust particles, they will scatter the light that is coming from. Okay, that scattered light, the path of scattered light you can see when you are sitting exactly perpendicular to the path of light. Okay, so this is all about the Tyndall effect, guys. So all these are example from a hole. Like even at your houses you must have seen, the moment you open the windows you can see the sun rays path, right? But in which direction if you stand, you can see that sun rays path only when you are perpendicular to the direction of light. Okay, so why the scattering is happening? Because the entire atmosphere is filled with smoke, gases, dust, and all these will behave as a colloidal particle. They scatter this sunlight all over. That's why, like exactly when you are right angles, you can even see the path of light moving through them. Okay, so that is all about Tyndall effect, colloids, suspensions, separation techniques, and everything, guys. So this completes the concept of the chapter. Hope you have understood all the concepts. If you have understood, if you have watched the previous video also, this is part 2, the previous video is part 1. Okay, so both parts, if you have watched and if you have liked, just like the video, share the video to all your friends. Okay, so see you with the next chapter and let me know which chapter you all need next. Okay, and notes is provided for this video. Do check it out. The fantastic descriptive notes is provided. Okay, thank you. See you in the next video then.